See here, this is the numerical from the thermodynamics. Okay, numerical session of the thermodynamics. Up to first law of thermodynamics, whatever the theory we have studied, based on that, this is the question. 2 moles of ideal gas expanded isothermally and reversibly. Isothermally and reversibly from 1 liter to 10 liter at 300 Kelvin. Then enthalpy change is. Then enthalpy change you have to find out. Okay, that is the question. Now you can start solving and let me see who can answer this. Okay. Now this is just a previous entrance question. Okay, this is just a previous entrance question. Understood? This is why thermodynamics is very difficult because every word changes the procedure. Here the keyword which you should remember is ideal gas isothermally. Okay, ideal gas and isothermally. Okay, then formula which we should use is delta H is equal to N into Cp into delta T. Okay, N into Cp into delta T. That means delta T is 0 isothermal. Okay, so during isothermal delta T is 0. So once it itself is 0, nothing is possible to change the enthalpy. Enthalpy will remain same. So change in enthalpy will be how much? 0. Okay. So what is the key word here? Isothermally. Once isothermal means a process which is carried out at constant. A process which is carried out at constant temperature. Once process carried out at constant temperature, change in temperature is 0. Therefore, delta H will be 0. Is it understood? Okay. Now let us see the next question. Okay, next question is here. Here there is graph is given. A substance from condition A to is taken to B and taken to C. Okay, a substance, a system from condition A, state A to the B and C by the different paths. Okay, from A to B it is carried out isothermally. The process used is isothermal process. Okay, and from A to C, it is adiabatic process. Okay. So which of the following statements are carried out? Reversible expansion. Okay. Obviously, there is increase in volume here. So expansion only. And it is carried out reversibly under isothermal and adiabatic condition. Then we have to tell about the which options are correct. Okay. So this question I think I included in one of my quiz also, but most of them are not able to give proper answer. This is a multi-correct option. It is advanced question. Understood? So with reasons I am intended to explain. That's why I have given it to you now. Understood? So during the quiz we cannot explain. That's why I have given it now, and some answers also started coming. Okay. Okay, I'm giving you explanation part of it. This is just a theoretical based question. Okay. Now, first this graph, you should memorize it. Understood? When we are reaching from the same point to the isothermal and adiabatic. Main problem is that if the curve is like this, it is easy for you to identify it is a isochoric. If the curve is like this, it is easy for you to identify it is a isobaric. But the curve is like this. Okay. Here, how many things are changing? There are both things are changing. Okay. What is that? Pressure is changing, volume is changing. So we cannot, and on the graph, x and y axis, pressure and volume are only there. So whether it is carried out isothermally or adiabatically, we cannot say. From the PV graph, we cannot say the just by a glance, we cannot say it is isothermal or adiabatic because in both condition, pressure and volume will change. In both condition, what happens? Pressure and volume will change because of which it is very difficult to identify whether the reaction is adiabatic, whether the reaction is isothermal. Understood? So for that, what you have to do at both condition by using PV is equal to nRT. Okay, whether it is isothermal or adiabatic, here and here we will use P1 V1 by T1 is equal to P2 V2 by T2. Otherwise, moles are given. We will find out both temperatures. Okay, if these two temperatures are same, that means it is isothermal. If these two temperatures are different, then it is adiabatic because the curves appear same or not. Okay, so the main problem with the adiabatic and isothermal is both pressure and volume changes. But if it is isothermal, temperature at both condition will be same. Understood? That is one thing from the graph you should identify. Okay. Now let us see. First, T1 is equal to T2. T1 is equal to T2. Just now I have mentioned that it is a isothermal. So temperature must be same. So T1 must be equal to T2. That is A is correct. Okay. T3 greater than T1. How it is possible? It is expansion. What it is? Expansion. So during expansion, what happens? Work done by the system. So once it is using the system energy and not getting anything from outside, is it possible that temperature will increase? Some of the internal energy is consumed for expansion. So if energy is consumed, leftover energy will be less. Leftover energy less, that means temperature will decrease. Here T3 less than T1. What it should be? T3 should be less than T1. That's why this is wrong. Why it is wrong and what should be the correct option? I think now clearly understood. Now in the previous lecture, I have explained in the theoretical session. I have explained work done in isothermal, work done in adiabatic. How to find out area under the curve? See here, this is the area under curve. From up to here, we are covering for the isothermal, and for adiabatic only up to here we are covering. Okay, adiabatic from here to here, from isothermal from here to here. That means we are covering more area in isothermal. So area under curve is a significance of the work done. Therefore, work done in isothermal greater than adiabatic. That's why this option is correct. Why this option is correct? Is it understood? Then coming to the D. Okay. So delta U isothermal greater than delta U adiabatic. Delta U isothermal greater than delta U adiabatic. Simple, it is correct. Okay, because adiabatic means no heat coming out from the outside. Therefore, internal energy will decrease. Okay, therefore, internal energy will decrease. Okay, because of that reason, delta U isothermal. Here, temperature coming out from the surrounding is permitted. Here, temperature coming out from the surrounding is permitted. Therefore, it is correct. Okay, so why ACD is correct and why B is incorrect? I think now it is understood. Especially don't leave any graph questions. Graph questions and keywords identification is most important for the thermodynamics. Okay, is it understood, students? Now we will do one more question. Okay, next question is find work done when 18 ml of water getting vaporized at 373 Kelvin. Water getting vaporized at 373 Kelvin in a open vessel. In a open vessel. See, every word is very, very important. At 373 Kelvin. At 373 Kelvin in a open vessel, assume ideal gas behavior. Assume ideal gas behavior. So this question appears to be a chemical thermodynamics. Okay, but it is not so. Okay. So when water evaporates, when H2O evaporates, the product is in gaseous state, reactant is in liquid state. So there will be expansion. What it is? Expansion. That means expansion work only we should calculate. And open vessel is there. Open vessel shows that it is a P external. What external? P external is equal to 1. Open vessel means P external is equal to 1. Okay. Now we will use formula. What formula we are going to use? PV is equal to, sorry, work done is equal to minus P external into delta V. Okay. But main problem is that delta V is final volume minus initial volume. We got initial volume only. After escaping into atmosphere, what volume it is going to occupy, we don't know. Okay. For that only this word is given. Ideal gas behavior. Okay. So that means he is asking you to use the PV is equal to nRT. Okay. PV is equal to nRT. This we can use only for the product because it is in gaseous state. For this, we cannot apply. Is it understood? So V final is equal to nRT by P. Okay, nRT by P. Open container, therefore 1 atm. 18 ml means 18 grams. Density of water is 1. So moles will be 1.0821 into temperature is 373 Kelvin. Temperature is how much? 373 Kelvin. Okay. 0.0821 into 373 by 1. Okay. On simplification, you are going to get 30. You are going to get 30.623. On simplification, how much you are going to get? 30.623. 30.623. But it is in what? Final volume, not it is the final answer. Okay. Now we have to substitute it in the formula. Okay. Substituting in the formula, W is equal to external pressure is 1 atm. Okay. Change in pressure is, sorry, change in volume is 3.623 minus 0.018. Okay. 0.018. How much it is? 0.018. Where I got it is in liter. It is in liter. So this is also is going to be in liter. Understood? 0.018. So now on simplification, you will get around 30.60. 30.605. Okay. But units you should be understanding. Units are in liter atmosphere. What atmosphere? Liter atmosphere. Units are in liter atmosphere. Is it understood? This is the work done. This is the work done during vaporization of 18 ml of water in a open vessel. Okay. Okay. Here answer is very simple. Answer is 0. I told you in the thermodynamics. I told you in the thermodynamics. Every word is important. Here it is evacuated. Evacuated means there is no P external itself. Okay. Work done is equal to minus P external into delta V. So here external pressure itself is 0. So therefore, where I could come to know evacuated, that means outside the container. Suppose this is 10-liter container. Okay. And it is 100-liter container. But when it is joined together, okay, it is already evacuated. There is no force acting from this side. So no force acting, no energy required, no work required. Understood? So this is 0. Therefore, it can free expansion. What it is called as free expansion. When free expansion work done is 0. Is it understood, students?